Hello everyone, February the 1st. Alright. I have 3 days, including today, to finish reading The Man from the Future, The Visionary Life of John von Neumann. I have learned this name because he has this called von Neumann architecture, which is basically how modern computers that we're using, they're built based on that architecture. That's how I know him, know his name. I thought he was just a big name in computer, but dude is genius from so many different areas. Yeah, there are differences in people's mind capacity, and then at least according to the book, according to a lot of anecdotes, he is truly someone above everybody else. They said his mental capacity, his brain is working at a higher level than even Einstein or Kurt Gödel, which I completely believe just based on his contributions. Like 20, just barely 20 years old. All the contribution to the set theory. That was amazing. Yeah, he is a polymath. So this type of person is a polymath. Once in a generation. No, once in multiple generations. Yeah, very impressive. But I'm going to do impressive thing too. I'm going to read this book, all 320 pages in 3 days. We'll do it. Why? Because I did not read it early enough and then I need to return it. I got it from the library. Oh, look at this. We reached 1,000 questions yesterday. Alright, so today, of course, we're gonna do this. So we got easy again, which is good. And then I read the binary index tree. So we're gonna try that without looking at the implementation. I have my implementation of BIT, so that will be good. And we'll finish this, and hopefully, we have time for this. Oh my god, we're still stuck here. It's been, oh my god, it's been a long time. Alright, what's this? Okay. Okay. Order of the alphabet is some permutation, Subsequent words written in the alien language. And the order of the alphabet return true if and only if the given words are sorted lexicographically in this alien language. Oh, I remember. I think we can do key. Oh, how do you do key? That is a very good question. How do you do key? I don't know how you do key. Sort based on what? Exactly, based on what? What is the lexicographical order? We compare the words letter by letter, right? And then if the first letter is small, then that one will rank first. So I'm not quite sure how we can make this comparison easy enough. What we can do is reorder the words. We reorder the words. So this is the order, right? Which means H corresponding to A, L corresponding to B, right? So if it's HELLO, that's just A, B, C, D, E, F, G, A, G, right? We just swap it and then sort. Now that is possible. So basically, we are going to swap this, sort it, see if it's correct. Okay, so that's our strategy. Is alien sorted? So what we're gonna do is to create a mapping, right? We're gonna say for x, y in zip order, and I think import string dot, actually I forgot lowercase, ASCII lowercase, yes, ASCII lowercase, so we need this, ASCII lowercase, and then that's gonna be, this is order match to this, okay? And then we're gonna say converted shall equal to for word in words, and for each word we are going to list word, okay? And then for letter in, actually say for letter in word, m letter, all right? And then I'm gonna say this dot join all of this that is converted, okay? Okay, so that's converted, and we say return converted equals to sorted converted. That is my solution. So first one should be true. Second one shall be false. Third one shall be true. No, false. Words is order. Forgot order. Oh, jeez, man. Yep. It'll work. Okay. Nine. Come on. 953. Convert each word to regular alphabet with a letter corresponding to the order. It doesn't really make sense, but yeah, you know what it is. Oh, this is what? That's 01 because that's on 26. This is ON. ON times words length. So OMN, okay? OMN plus n log n, where m is the average length of each word and n is the length of words. What's the solution here? I was able to think about this, but they didn't use sorted, which I realize it's quite smart. And this is O(n). This is actually O(n) log n, but it's fine. All right, so that's that. Let's implement this. All right, back here. So solution 5. I already read it, so I know what it is. So basically, we are going to sort based on score. Okay, so we're going to sort based on score. Yeah, let me write this. So this is the BIT solution. We sort based on score first, and then age. Then we iterate through score age, and for each score we want to find the max score that can be obtained by having players for each score S and its age A, right? We want to find a maximum score that can be achieved by all previous players with age smaller or equal to A. Now, since we have sorted by score, it is guaranteed that all previous players have score smaller equal to or equal to S, which means the eligibility of choosing the current player is by finding the previous which means the current player is eligible if all previous players have age smaller or equal to A. Now, to find the max, right, of all ages up to A is a BIT problem. Thus, we create a BIT with the total length being maximum age plus 1. Then, for each player SA, we query BIT. We get the max score up to A by bit.query A, and we then add S to it, right? Add S to it to form the max score up to the current max score up to A. Then we do bit.update A. We record all the max score along the way. Okay, BIT. We have a BIT, but I forgot. Do you want to try to write it yourself? Oof. We need n. So self dot. I don't even know what I used to call it. Array, right? It's gonna be an array. Should be 0 times n plus 1. Or 0 times n. N is the total numbers, right? The total number. Let's do 0 times n. def we have a query index, or query the index, right? Oh, I don't remember. I'm gonna just mess up, I'm pretty sure. What do we have? Snippet. Bit. Alright. Bit n plus 1. N is the size of the range, including. Okay, let's just copy and paste this whole thing and then we'll understand again. Alright, bit. So n is the size of the tree. Use 1 based bit. This array size must be 1 larger than the original. The size of the range, including minimum, including the maximum. Minimum and maximum. Minimum would be 1. Maximum is max age. So we put this in, okay? So update the value at position by adding delta. Okay? We'll do that by adding delta. All the ranges that contain position. Given position. So we need to minus 1. And then I equals position plus 1. That's position. Well, this is smaller than bit I. We'll do this. And then, I don't want to understand this. Bit. I and minus I. I and minus I. Query. Then this is not plus equal to. Because I want the maximum, right? So when you update, you don't add, you get the current. So current max, okay? So update the value by changing it to the current value. Current. If current is larger. Yeah, we don't need all this. Alright, so this shall equal to maximum self.bit I and current. Query the max value in the range 0 to max R. Find by self.update. Yes, and not necessarily sum. Okay, so rest is this. This is this for I. Rest shall equal to the maximum of rest and this, right? I minus equal to this and return. Okay, so with bit, we sort, right? And then we say bit equals, we need maxes, so min age, max age equals max ages, mean ages, right? Then bit equals bit, that should be max age minus mean age plus 1. That's the total count. And then we say for SA in sorted. Yeah, we don't even need to find. I think this should be sufficient. We sort this, right? Then what? So for each, we're going to say rest equal to 0. Then we can find the pre-max shall equal to bit.query a. Age is a, but the index, the position, shall be a minus mean age. Right? That is the position. Because its main age position is 0. So we'll query this, which means it cannot be larger than this position. So that's the previous max. Then we say bit dot update a minus main age. We update with pre-max plus s, which we might as well just do this, but let's do this later. And then pre-max current max shall equal to pre-max plus s, right? And then we'll update current max, and the rest equals the maximum rest and current max, and then we'll return rest at the end. Let's see if this one works. Does not work. List out of range. Huh. That is interesting. Oh. Age, school, age. No, that's right. School and age. We do age, score, doesn't matter. We do score, age. We first saw score, then by age. How come it's not right? The total count, right? The maximum age plus the smallest age plus 1. That's the total count. And the position should be the current age minus the minimum age. I don't understand. I do not understand. Max range. How did n plus 1? Which one is the first one? Oh. Age print bit dot bit. Huh? Oh, you gotta be kidding me. This is min. This is max. You gotta be kidding me. Each one's log n, so this is O(n) log n. Oh, I forgot to define bit. Oh, dude. Oh. Oh. I mean, this is exactly the same idea as this. You sort based on this, and then for each one, I was trying to do the maximum age. Actually, yeah, maximum age, exactly, maximum age. If it's larger than maximum age, I just do it. And then here, you see, we will add this, the current score, and then for the previous, for the previous, we're just trying to see, right? We're trying to see which one is max. We're just finding the maximum, yeah. This is finding the maximum of everything that has shown before in a smaller age. Right? Now this is age. This age is larger than me. For each age larger than me, we do this and myself. Yeah, it's similar idea, but this is really neat. Damn. BIT. Huh. Yeah, it is the maximum until something. Maximum until something. It's very, very good. Alright. Do you want to continue with this? We can. Just work a little bit on this. Wait, what is this? One of the questions? Yes, it's one of the questions that we score correctly, but this one we score wrongly. Oh Lord. Oh. Hold on, I need to remember. I need to remember what this one is. Main powers. So we need to let me see the powers first. Okay, this is the powers. Let's get it. The powers. 127, 162, 135, 94, 72, 59, 117, 18, 4, 226, and 138. My answer is 131, but they say 138 is possible, and the range is only 1. Okay, so 138. So 138, the first one is lacking. How much is the first one lacking? Well, the first one is lacking 138, 11. Second one, we don't need to care. This one lacks 3. Second one, 138 minus 94. That's 44. Minus 72. That's 66. Minus 59. 79. 118. That's 20. 194. Yeah, that's more than enough. That's more than enough. That's more than enough. So basically, we can add 11, and then it's 1. Because actually, you can start it here. So we add 11. So these two are done. And then for this, we can add. We have to handle this. So we add 66. Okay, so we added 66. This one has 13 left. And this we can add 13. Well, we need to add 20. So in total, we need to add 11 plus 66 plus 20. That's 97. Or I add 79 here. Then we cover both. So that's 79 plus 11. That's 90. But we're not covering the 44. How are we? Huh? How do you figure? We only reach one. Okay, what if we do 44 here? And then we have 22 left. Then 79 minus 22. We have 57 left here. Then we have to do 57. Then it's 44 plus 57. That's already 101. How? How are we doing this then? I am not sure. I can't seem to even figure it out. Huh. Yeah, I don't think the computation is wrong for others, but you sure? You sure you got all the right? Sure you got everything right? Yeah, I expected a 138. K is 90 is 138. Yeah? I don't see how I made mistakes. 79 needs 79, right? 38 minus 72 is 66. 138 minus 94 needs 44. 138 minus 135 needs 3. 131 is 11. So we do have 11. I mean, I already constructed on every places, and it just doesn't write. And it's not right. Like this 11 we have to do no matter what. And when we do the 11, we might as well just cover all these. Right? And then we might as well do, we can do 44 here. I try, we do 44. Then we have 22 left. Right? And we have 35 left. That's 22. And then we have 35. and 20. So at least need another 35. So it'll be 11 plus 44 plus 35. Oh, shoot! That is 90. That is 90. What the actual hell? How did you not do that? I was complaining, and then realized, hold a second. It was correct. I tried 156. Too much. Or try 140 is too much. Try 132. No, that's low, high. Now try 128. Wait, hold on. Yeah, try 128. Wait. We try. What about low, high, mid? Why do you do low, high, mid? Low, mid, high. It's easier for me to walk it through. Okay. Try this. It's not possible. Try this. 132 shall be possible, but I said it's not possible. All right, 132. So we have these, right? 132. How is that not possible? Okay, so I is 0. So we need the current minimum. So we have the limit is plus 2. So it's going to be this 0 plus 2. So 2, right? So I equals this. Minimum is 127. Plus equal 1. And I plus equal 1. 3 should come out. So allowed should be now. Let's do this. Print allowed. Print I and allowed. Okay, 132. 132 minus 127 is 5, so I had 85. That's correct. Next one should be handling this. 3 plus 2, 5. So I can cover all these. So the minimum is 59. Minimum is 59. So we want to satisfy 59. So we need 132 minus 59. We need 73. Right, so 73 with 90 minus 5 minus 73. Then we have 12 left. And at the end is 118. Well, I need 14. Ooh. Oh. That was the problem. So for 127, right? 0, 1, 2, 3, 4, 5, 6. So this requires 5. Done. Now I do these 3. Let's say I will choose to get this, which means I shall not choose to get this. I shall choose to fulfill the first one. I was trying to say, if I fulfill the last one, then everybody else will be fulfilled. Like if I place it here, but then you have waste. Yeah, you have waste. You shall be fulfilling 72, right? If we fulfill 72, 132 minus 72. So we'll take 60. This will be fulfilled. This would take 60, right? So 59 plus 60, this will become 119. And then 119, 118 will take 12. So it'll be 5 plus 60 plus 12, 77. Yeah, this is possible. Oh, dude. So you would be right if we just start from the front, right? If we start from the front, 94. 94, 132 minus 94. I'll need 38. Okay, I'll need 38. So 72 plus 38. This will become 110. 59 plus 38. This will become 97. And then at a 110, I do 132 minus 110. This 122. 97 plus 22 will become 119. And at the end, I need 12. Well, I need 11. And this one will become 129. And this will... No, this one. No, this need that one. 132. Right, we need 132. 132 need 13. Right? And this 132. And the 13. And plus 13 is 131. And this requires 1. So in total will be 5 plus 38 plus 22 plus 13 plus 1. 79. So that's possible. Okay, so now what? We cannot find the minimum. And we cannot go one by one because that just costs too much. How do we efficiently? So for everything, we give a value, right? And then we walk to the next one. Right? The next one we add whatever value we need to add. And then we walk to the next one. And we add whatever value we need to add. And then we need to drop the previous one and add this one. Ooh. There's gotta be a better way. All we need to know is going through the current stretch, and we need to fill all of them, right? And in the current stretch, and we need to fill all of them, so we can find the current stretch. And the best way is always to fill in the center. But what if we fill in the center doesn't fill on the sides? Yeah, what was the problem if I do 59? If you do 59, 132 minus 59, you need 73. Right? And that 73 is, and then we have lots of waste. Right, we have lots of waste. So are you saying we shall find the maximum first? We fill the maximum. No. I think we should start, because we know for this one it's on the edge, right? So we know how much it needs. And then move on to the second one. We have a spillover, right? Because within this range, whatever we do here will affect everybody else. And whatever we do here will affect everybody else. And in fact, when we do here 94, right? When we do 94, a rolling window, hold on, a sliding window. So this 132 minus 94. So here we say we need 38. Okay, so the current value is 38. So everybody inside should add 38. And then I move on to the next one. And then when you're gonna add 38, okay, we add 38, and then that becomes 110, and then we need to add, so we need to add another 22, right? And then we move on to the next one. So which means the total accumulated for this is going to be 38 plus 22, right? So this is going to be 38 plus 22. So we have accumulated sum at the same time, 60. So this is going to add 60, so 119. So this will need to add 13. So put 13 here. Okay. Now we get out to the new one, right? To the new one. And the new one, we need to see this position was the first position. If it's too much, then this one need to be popped, right? Which means, and add here is actually at 73. So if it's too much, it should be popped, which means for 118, right? For 118, we can add 73 minus 38, which is 35. So we can add 35, and then 118 add 35 is already done. This 150 was already done. So the total added, right? The total added is just this total value. The total value we have 78, right? 78. A rolling. So everyone need to add this or put it in. Next one we need to add this or put it in. Next one we add this, put it in. But every time we check the previous, right? And we have a sum. And this is a rolling sum. So what I'm talking about is we're gonna do it slightly differently. And we know the total length is 2 times r plus 1. That's the total length, right? That is the total length. So current to me, no, that's not how we want to do. What do you want to do? We need to have a low and high. Nah, not really low and high. We have a I, and we can just, we say for I in range, land low powers, right? And then for each one, we're gonna maintain a deck. Okay, from collections, we're gonna import a deck. Right, so we're gonna have a deck, and we're gonna do it outside, which is added power. So added power should be a deck. Okay, so total added is gonna be 0. right? Allowed to add is going to be 0. We have 3 things. Okay, allowed to add. Okay, so we have this, and then for each one, we shall say while added power and we need its index and the current index. So it's gonna be, ooh, I don't even need the current index. I just need the previous index. So I can say IP in low powers. Okay, for IP in low powers, well added power and added power 0. We can say 0 is also the I index, which means the current minus this, right, plus 1 if it's larger than 2 times R plus 1. So we can remove this plus 1, which means the current is out. So the current station is outside the influence, right, of the first station that gets added, that gets additional power. Thus, it cannot take the additional power from the first station in the deck. In the deck that gets, thus it cannot take from the first station. That's what I want. So when that happens, we can say J, well, actually don't need it. PP equals low power dot pop left. Wait, I think it's no underscore, just pop left, and then allowed to add minus equal to PP. Right, so we do this, blah blah blah, and then we have allowed to add. So now we can say to add shall equal to add shall equal to the minimum maximum of 0, and P is the current power plus allowed to add, and then we'll have the mid minus this thing. I can say mid minus P minus this, right? This is to add. And then we have the to add, then total added plus equal to add, and we shall say if total added is larger than larger than K, right? If this is larger than K, then we're gonna break this for loop. Otherwise total added is fine. Then allowed to add plus equal to add, and added power dot append what? Dot append the current index, right? Index and to add. And blah 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 blah. So else, which means everything's fine. Then we say low is this, and we'll continue. Otherwise, we see this. Let's see. Eesh. Low powers. It's not low powers. It's added power. Dot pop left. Oh, we pass. That's nice. Let's comment these out. Try all these. Oh, we pass all of them. That's promising. That's very promising. Alright, we're gonna run these. Let's see if it's still promising. Oh, it's promising. This is very promising. And in fact, we don't need allowed. And this can be in here because I don't need low power. It's only 2 times. I can do an iterator, so it'll be easier. So I don't need this. And then I don't need I equal to 0 either. So we have this, IP, while, this to add, if this. Yeah, and then we do this. Then we do this. Alright, one more time. One more time. Okay, let's do this. Come on. Come on. Come on. Oh, yes. Oh, finally. Finally. Oh my god. Now we need to redo this. Oh, tough. But we find the solution, right? We know how to do this. It's just alright, we know this is a binary search problem from the start, but the implementation still evades us for have evaded us, has still evaded us for quite a while. Right. First, we need to obtain the current power level for each station. I tried to use a sliding window for this, right? But it was kind of complicated. Thus, I opted for a simpler prefix sum. Then we do the binary search, right? The trick is to find a way to check whether current power level can be reached given R and K. Now a simple case is when the smallest, right, on the lowest powered station requires much more, right? Much more power than K. We can immediately consider this case impossible. Otherwise, we need to go station by station that is currently lower than the required, than the desired power level. In implementation of sliding window and dynamically updated power allowed to add power determines what each station can get from the powers given to the previous stations within the R range. Yeah. That's that. The rest is formality. Formality for binary search. Oof. BIT solution. Oh, it's not on log n. It's on log max power. Some stations plus k. Yeah, that's not right. Yeah, and log. Sum of powers, sum of stations plus k. Yeah, that's true. Yeah, I like mine, so I'm not gonna bother, but oh, I should put that in nightmare. Come on. That is a nightmare. That's a nightmare problem. So one of the problems is, you know how to solve it, but whew. It is greedy, right? We try to satisfy each one, and then because that's the best one to go. Yeah, we just need this little deck. Added is the total power added so far. We use this to check against k. allowed to add is the power allowed to be added for the current station. Allowed to add is updated dynamically because when the current station falls outside the range, any added power at the beginning of added power queue DAC must be removed from allowed to add. How much power is allowed to add to the current station thanks to the powers added in its previous neighbors within the R range. I like to post this. I think it's good enough. So binary search with sliding window to determine possibility. I'll say Python binary search sliding window. Yeah. Where's your submission? Actually, I always wonder if you go this, can you see? Oh, you need to log in to see. Huh. Why bother? Okay, that'll be it. I finally got this one. I'll see you guys tomorrow. Adios.